So viewers, moments question 9, we need to find the weight of the UDL per metre if the supports are balanced. In other words, the situation is in equilibrium, so therefore the sum of the moments is 0. Let's take A to be the pivot and clockwise to be the positive direction. Okay, so first thing we need to work out here is the length of the UDL. So the UDL length will be, well, we can see that between the two support forces A and B we have 11 metres. We also have 1 metre between A and the left hand end of the UDL, and the right hand end of the UDL is 2 metres back from B. So all in all, that tells us that the UDL length must be 11 minus 1 minus 2, which is 8 metres. And where would its centre be? Well, if it's 8 metres long, then half of 8 metres is 4 metres. Have to add in that 1 metre between A and where that UDL begins. So the centre is therefore got to be 5 metres from point A. Okay, so we've worked out the UDL. Now we need to work out what our moments are. So our moments, if we take A to be the pivot, are going to be, due to the UDL, it's the length times the unknown weight per metre. So if we say that the weight per metre is some letter, let's call it F for now. So we've got the weight of the whole thing is going to be 8 times F. 8 metres long times F kilonewtons per metre. Okay, so we've got 8F as the force, and the unknown distance is, well, the distance we do now know, it's where the centre is, which is 5 metres from A. So that's going to be times 5, and that will be a clockwise moment. The weight of the UDL will act to rotate things clockwise around A. We also need to look at our other down force, which is going to be the 10 kilonewton force. So that's going to be 10 multiplied by its distance away from A, which is it's 1 metre back from B, which means it's going to be 11 metres as the distance between the two support forces, minus 1 metre, giving us 10 metres. Okay, and then we've got the anti-clockwise moment, which is due to support force B, which is, we're told that's actually 12 kilonewtons. So this is going to be minus 11 as the distance times 12 as the force equals 0. And because we're not really interested in what A is, we can just solve it from here. We can just solve that equation and then we have our answer. Okay, so 8F times 5 is 40F, plus 10 times 10 is 100, minus 11 times 12 is 132. So we've got 40F minus 32 equals 0, so therefore 40F equals 32, and if we divide both sides of this equation by 40, we get F is 32 over 40, which is 0.8. So our unknown weight per metre is 0.8 kilonewtons per metre. Okay, thanks for watching. Over and out.